Okay, move to the next question, and in this questions I am taking exercise is in this exercise it is given that limit x approaches to 0, and our function is it is 10x and raised to the power sine 2x. Okay, again, as we have to in the previous question, we take the natural log. We will first consider that it is equal to y, and then we take the natural log, and by using the L'Hopital rule we will again solve it. So first we check that either it is in indeterminate form or not in determinate form. So suppose if it is not indeterminate form, that means that we didn't apply the L'Hopital rule. So L'Hopital rule will be applied only in one case, and that is the 0 divided by 0 form, and other is indeterminate form. Okay, so 0 divided by 0 form is also called indeterminate form. Okay, so now let y is equal to 10x, and it is sine 2x, and taking natural log on both sides. When we take the natural log on both sides, then by the property of log, we can write this power sine 2x before log. Okay, sine 2x can be written before log, and natural log of 10x. Okay, sine 2x, natural log of 10x. Yeah, so can we write sine 2x is in just like here, the limit is we can also apply the limit is it is x approaches to 0. On the left hand side, of course, the limit is x approaches to 0. Okay, so yeah, now we write which is equal to limit, and limit x approaches to 0. So natural log of 10x, and this sine 2x can be written as cosecant 2x in the denominator. Now check that either it is 0 divided by 0 form, and you know that when 10x 0, when we put over here 10 0 means 0, and natural log of 0 means infinity. So cosecant 0 is again infinity. So we can say that now it is infinity divided by infinity form, which means indeterminate form. So what we do when we get an indeterminate form, we take the derivative of the numerator terms and the derivative of the denominator terms, means we apply the L'Hopital rule. So applying the L'Hopital rule over here, which is equal to limit x approaches to 0. So what is the derivative of natural log of 10x? It will be 1 over 10x, and the derivative of 10 is secant square x divided by cosecant 2x. The derivative of cosecant 2x is minus 2 cosecant 2x and cot 2x Okay, so again, now we simplify it, and after simplifying we'll again check that either it is in determinate form or indeterminate form. Okay, 1 over 10x, it will be cos x divided by sin x. Okay, cos x divided by sin x, and what is secant square x? It is 1 over cos square x, and divided by minus 2 cosecant x cot 2x minus 2 cosecant x minus 1 over sin x, okay, minus 2 over sin 2x multiply by cot 2x is cot 2x is cos 2x divided by sin 2x, it is sin 2x, okay. And after simplifying yes, cot 2x, and I'm going to simplify it, okay. It will be cos x divided by sin x and cos square x. Remember that is cot square and this square is cancel, okay. And it is 1 over sin x and cos x, and this will be equal to limit x approaches to 0 and 1 over sin x and 1 over it will be 1 over sin x and cos x divided by minus 2 cos 2x, 2 cos minus 2 cos 2x, 2 cos 2x divided by sin square 2x, sin square 2x, okay. Now this is equal to limit x approaches to 0, so 1 over sin x and cos x, 1 over sin x and cos x we can convert into sin 2x, okay. This is equal to sin 2x, so multiply by over here, multiply by 2 over here, and multiply by 2 over here, it will be 2 divided by sin 2x, and this will be equal to sin square 2x divided by minus 2 cos 2x. So square is cancelled out with this one, and it will be equal to, so this is equal to limit x approaches to 0, and this, and x approaches to 0, and this is 2 is also cancelled out with the 2, it minus sin 2x minus sin 2x divided by 2x divided by, it will be cos x, it is cos 2x, this is cos 2x. So when we apply the limit, it will be 0 divided by 1, so this is equal to 0. And since our limit, the limit is x approaches to 0 of y is equal to 0, which means that natural log of y, sorry, it is natural log of y, limit x approaches to 0. So it means y is equal to e raised to the power 0, and the limit of y is x approaches to 0. It is obvious, okay. This is equal to 1. So this is the proof of this question, okay. We move to the next exercise, another exercise. Before moving to the next, take a little look at this question. How we do it?